Modern society benefits from tons of scientific data, but how can it be used to better predict the future? Our next guest is here to talk about just that. Peter Dodds works for the UVM Complex Systems Center. He's hosting a symposium on Monday. It's called Prediction, the Next Big Thing. Peter, thank you very much for joining us. Yeah, absolutely. So what kind of predictions are we talking about?
Of all sorts of systems. So everything from the weather, which we've made a lot of headway in, to wars, financial systems, really every kind of big system you can imagine. We are trying to get somewhere with prediction now.
You take the data, you take the information, and then you try to turn it around. We were talking a little bit off camera. Big sports fan, obviously, and in the past half decade, really, and maybe a little bit before that, but analytics, the use of numbers to try to predict future performance has exploded, not just in baseball with Moneyball, but across the board. Right. That's kind of something.
It's a fantastic example because there is so much repetition in sports that you can actually, we've had to find this out. We've had to measure what people do. And then translate it into predictions, and we've been able to see that that works well. So the weather, there's a limit. So we can go out 3, 4, 5 days, maybe 10 days. We can make predictions about that. But we understand fundamentally, we have fantastic data now, but we understand fundamentally from equations and so on that there is a limit to what we can do with that kind of system. There's the phenomenon of chaos, that there's a mess happens after a while. So there's just a horizon. And we have to be fine with that. We can't predict 30 days from now. Other arenas like sports, well, maybe we can predict a whole career, but there are things like catastrophic injuries. They're much harder to predict. So there are some things in there that maybe we'll never be able to quite get a handle on.
So is part of what this symposium is about kind of the ideas that are percolating about how to best use that information in all these different avenues? Yeah,
so we'll be showcasing some great examples. We have a couple of world-renowned speakers coming in. There's Cesar Hidalgo from the MIT Media Lab, who's done a lot of interesting things on who's the most famous person in the world, or has been, and how that comes about. There's Neil Johnson from the University of Miami, formerly of Oxford, who's done a lot of things on work with conflict. So it's surprising. There's a lot of structure, actually, in terrorist activities and traditional wars. There's a lot of statistical structure in there and a lot of repetitive behavior that you can kind of illustrate, all the way from just simple conflicts, like actually person-person conflicts. It all scales up.
Is that where the trends are going now, that people are discerning data from places where you didn't really think there was data maybe a generation ago?
So this is the big transition. So we're talking about big data, the time of big data. It's the transition of all scientific fields. Eventually they go from data scarce to data rich. We saw it in medicine, we saw it in astronomy. Suddenly things are completely different, and the skill sets you need are different, and the questions you can ask are different. So once you've got this data rich environment, the big scientific question becomes, are your theories good enough to actually predict what's going to happen?
And we're talking about a couple of examples where we're finding places where predictions can work. Are we also, by doing that, seeing avenues where predictions can't really work?
Yeah, so that's a really a profound result, I think. And it may be, say, for financial systems, for certain human systems, and as I said with the weather, there are limits that we'll actually be able to define quite well. We'll be able to say, okay, you can't tell what's going to happen in 40 days with this kind of thing, but we can tell you what will happen tomorrow. And that's a great result. That actually, we'll be certain about our uncertainty.
Yeah, knowing what you don't know is almost as comforting as knowing what you can know.
It's extremely important.
So talk a little bit about this, the Complex Systems Center at UVM. What is it? What does it do?
Yeah, so it's an umbrella group. Of course, we've had disciplines for a long time now, and it's an umbrella group that brings people across the university together. It's a research and teaching enterprise. And so systems is really the big story. If you look back in time, we had 200 or 300 years of figuring out the small parts of systems. Atoms, it's only 100 years ago that we were really sure about atoms. DNA, that took us a long time to figure out that we're made out of this DNA thing. And so from there, we're starting to understand how these systems work. And of course, we can make them and create them. We've created our own social systems, and we have to understand how they behave. So there's a tremendous amount of work in science going forward for really hundreds of years of understanding, creating systems. And so we have people in robotics, we have people working on large-scale social systems, measuring happiness of populations, how things spread and contagion. We have people working on the power grid, when that thing might explode. That's incredibly important. issue. So there's a really, and the data story is making it possible for a lot of people to talk to each other, because handling data is a big deal.
And get that information out. And it sounds like it'll be a fascinating discussion on Monday. Peter Dodds with UVM's Complex Systems Center. Thank you very much for joining us, giving us a preview, preview, the next big thing. Monday from 1 to 4 at the Davis Center at the University of Vermont. It is free and open to the public.